Once upon a time, South America lived harmoniously alongside Africa, until a crack in the earth drove the two continents apart. This breakup began about 200 million years ago, during the separation of the supercontinent known as Pangea. Their proximity back then explains why the same plant fossils and reptile fossils like the Mesosaurus can be found on the South American east coast and African west coast. However, this evidence does not account for how the continents moved apart. For that, we'll need to take a close look at the Earth below our feet. Though you may not realize it, the ground below you is traveling across the Earth at a rate of about 10 centimeters per year, or the speed at which your fingernails grow. This is due to plate tectonics, or the large-scale movement of Earth's continents. The motion occurs within the top two layers of the Earth's mantle, the lithosphere and asthenosphere. The lithosphere, which includes the crust and uppermost mantle, comprises the land around you. Beneath the lithosphere is the asthenosphere, the highly viscous but solid rock portion of the upper mantle. It's between 80 and 200 kilometers below the Earth's surface. While the asthenosphere wraps around the Earth's core as one connected region, the lithosphere is separated on top into tectonic plates. There are 7 primary tectonic plates that compose the shape of the planet we know today. Like the other smaller tectonic plates, the primary plates are about 100 kilometers thick and are composed of 1 or 2 layers, continental crust and oceanic crust. Continental crust forms the continents and areas of shallow water close to their shores, whereas oceanic crust forms the ocean basins. The transition from the granitic continental crust to the basaltic oceanic crust occurs beyond the continental shelf, in which the shore suddenly slopes down towards the ocean floor. The South American plate is an example of a tectonic plate made of 2 crusts, the continent we know from today's map, and a large region of the Atlantic Ocean around it. Collectively comprising the lithosphere, these plates are brittler and stiffer than the heated, malleable layer of the asthenosphere below. Because of this, the tectonic plates float on top of this layer, independently of one another. The speed and direction in which these tectonic plates move depends on the temperature and pressure of the asthenosphere below. Scientists are still trying to nail down the driving forces behind this movement, with some theories pointing towards mantle convection, while others are examining the influence of the Earth's rotation and gravitational pull. Though the mechanics have not been sorted out, the scientific community agrees that our tectonic plates are moving, and have been for billions of years. Because these plates move independently, a fair amount of pushing and pulling between the plates occurs. The first type of interaction is a divergent boundary, in which 2 plates move away from one another. We see this in the Mid-Atlantic Ridge between South America and Africa. The next interaction is when 2 plates collide, known as a convergent boundary. In this instance, the land is pushed upward to form large mountain ranges like the Himalayas. In fact, the Indian plate is still colliding with the Eurasian plate, which is why Mount Everest grows 1 centimeter per year. Finally, there's the transform boundaries, where 2 plates scrape past one another. The grinding of the transform boundary leads to many earthquakes, which is what happens in the 810-mile-long San Andreas Fault. The moving Earth is unstoppable, and while a shift of 10 centimeters per year may not seem like a lot, over millions of years, our planet will continue to dramatically change. Mountains will rise, shorelines will recede, islands will pop up. In fact, one projected map shows the cities of Los Angeles and San Francisco on top of each other. Maybe South America and Africa will come together again too. Only time will tell.